Typically, Coho and Chinook or king salmon spawn and rear in flowing water, while sockeye salmon rear in lakes. Incubation times range from 50 to 200 days depending on species. In general, incubation time is shorter in systems where water temperature is warmer. The newly hatched alvin feed off of their yolk sac for several weeks. The alvins transition into parr at roughly 5 weeks and begin swimming and feeding. Understanding the feeding behavior of salmon is essential to understanding their growth and survival. Because salmon are a keystone species, understanding their survival is important to understanding the health of an ecosystem. Juvenile coho salmon may spend 1 to 3 years in fresh water before migrating to the ocean. Salmon that have longer or more difficult migrations to the ocean often stay in fresh water for longer times. They can inhabit fairly large regions of a stream. Most of the time, they will stay in schools or groups. Juvenile coho salmon forage in a wide variety of habitats, from slow-moving beaver ponds to flowing springs. Their diet for most of the year consists primarily of insects, including both aquatic insects produced from the river itself, such as mayflies and stoneflies, as well as terrestrial insects fallen in from vegetation on shore, such as caterpillars. In addition to insects, they will also eat eggs laid by adult salmon when they can find them. Fish are cold-blooded animals, and the temperature of the water where they live is an important aspect of their habitat. Cold water temperatures make for slow metabolism and slow growth, while warm waters can be stressful if temperatures are too high. Juvenile coho salmon will sometimes move among different environments within a river to find the best opportunities for food and growth. For example, some individuals can make long forays, as far as 1 kilometer, to cold environments where high-quality food, such as eggs spilled from the redds of adult salmon, are abundant, then return to warmer waters that allow faster metabolism and faster growth. This strategy allows them to have the best of both worlds. Trees and other woody debris fallen into the river can help create habitat complexity. Habitat complexity is important for juvenile salmon to provide shelter from fast currents as well as predators. Juvenile salmon may be found throughout large river systems, from steep mountain streams to slow winding creeks. At the origin of a river are headwater streams, meaning they are the beginning of a tributary. Headwater stream systems rely on allochthonous production, meaning they depend on organic matter from a terrestrial source. Aquatic invertebrates, referred to as shredders, feed on vegetation that falls into the water, and salmon feed on the aquatic invertebrates. Other insects that live in the vegetation may fall into the stream, providing a feeding opportunity for salmon. Larger, higher-order streams are wider, and the proportion of organic input is lower. These stream systems are autochthonous because they are more dependent on organic matter produced from algae and aquatic plant life. Aquatic invertebrates, called grazers, feed on algae. In these areas that are especially wide or lacking in vegetation, rocks and gravel are especially important for providing habitat for both insects and salmon. Juvenile coho salmon will use a foraging strategy adapted to their local environment and environmental conditions. When they are drift feeding, they face upstream and wait for food to come to them, rather than moving towards the food. Water velocities that are too fast or too slow can make it difficult for juvenile salmon to drift feed. In some places, the best strategy may be to hold a fixed position in flowing water and feed on invertebrates floating in the water. This behavior is called drift feeding. Juvenile salmon can drift feed most efficiently in clear, moderately fast water. Slow-moving water may provide insects to feed on at slower rates, while water that is too fast may require more of their energy to swim. Riparian vegetation can help lessen erosion that would make the water murky. Water that is too murky may make it difficult for drift-feeding salmon to see and identify their food items. After 1 to 3 years in fresh water, juvenile salmon will get ready to head to the ocean. They will undergo physiological changes that prepare them for the marine environment and take on a silvery appearance. This process is called smoltification. Stream-type juveniles rear in the stream for 1 winter. Riparian vegetation can help to regulate stream temperature over these winter months. Ocean-type juveniles do not rear over the winter. Larger smolts have better odds of surviving and returning as spawning adults to produce the next generation of salmon. There is not one specific type of stream environment that is the perfect habitat for a juvenile salmon. Maintaining the natural diversity of stream habitats is important to give salmon the best chance of surviving disturbances, such as long-term changes in stream flow and temperature.